Friends, and in this video we are going to discuss about a very powerful mathematical tool used in programming languages called as a recursion. What is a recursion? The recursion is just, you might have seen that in the programming, when there are a lot of functions that are there, then the one function calls the other function. This is a normal trend. But what about a function calling itself? This is called as a recursion. So recursion is a technique in which a function calls itself. So now let me create one code for this so that you can understand how Kotlin empowers the idea of recursion. So first we'll create a function main, and then we are trying to use a famous recursive model used as factorial. Factorial, you know that the factorial of a number is the continuous product of a number starting from the number itself and the returning back to 1, and with each step the number is decreased by 1. So like 5 factorial is 5 into 4 into 3 into 2 into 1, 0 factorial is 1, 2 factorial is 2 into 1, 3 factorial is 3 into 2 into 1. So here I'll create the first my function called as factorial. So I name it as fun facto, and this function will take the argument of integer number and x as int, and it will return a long value. Why long? Because factorials increment itself many folds, like 5 factorial is 120, 6 factorial is 720, like that. So if just 10 factorial, it will become a very big number. That's why we need a bigger size of the number. That's why I have taken the long. So here this is the function, and now so the function facto says that it will take the argument of integer type and it will return a long value. So return if I equal 1, if I is equal to 1, then what to return? So here I don't need I am using variable x. So if, then return x dot to long. So we need a return function that should be long. Else, if it is not the case, then what will return? Then it will return x into facto, and then you pass a number just less than 1, so x minus 1. This is done. Now I go and try to call the function. So here I declare one value, val I equals 5, and then I'll declare a variable result, and when I pass facto I, then this will return a value that will be stored into res. So now let me print result equal. So I want to make a message, so my message equals, and then result equal $res. So this way this works. So the whatever it returns, now let me call it. So I have written 8 factorial. This is a huge number, but first time let's see, because it can be 5 factorial is 120, then 740, so it's 40,320. So now if I make it as 5, then what will happen? So this will become 120. So there is also another function like finding the sum. So this is 120. So there is, I can design one more function recursive, and I'm going to name it as sum. So the name is function sum, and there again I'll pass any variable. I can write int I, and this will return type. This return type is also int. Okay, then sum. So what is our theme? We are interested in finding the sum of the square of the natural numbers. So I'll say that return if return if I or a equal 1. So if a is equal to 1, then return a dot to int, because a is already int, so a into a. Okay, so if is this, otherwise if it is not the case, then return a into a plus sum and then pass a minus 1. So a into a and then the sum minus 1. So this function is going to print you the sum of the squares of the first n natural numbers, like the 1 square plus 2 square plus 3 square. If I enter n as 5, if I make this I as 5, and instead of calling this factor, if I call my function sum and pass this value I, it means I'm passing 5, means I want it to compute 1 square plus 2 square plus 3 square plus 4 square plus 5 square. So now let's see what it gives me, and in the meantime I just calculate. So it is n plus 1 to n plus 1 by 6, so 55. So this is the answer. So if I write, suppose, just little lesser, like 3, so you'll get 3 square plus 2 square, 3 square plus 2 square plus 1, that is 9 plus 4, 13 plus 1, you'll get 14 as the answer. So if it is working correct, now it's working professionally, and it means that for n equal to 5 also it was true. This is the idea of the recursion, and I think that you have understood it well. Thank you very much. Just subscribe to our channel and keep watching our videos. Have a nice time.